let's look at the cochlea. So the cochlea, again, is the third part of the inner ear. This part has an area called a round window here, so oval window, and an area called the round window. So the oval window is the part that's being vibrated by the stapes. This is your stapes. So that one from the ossicles vibrates the oval window, which then sets in motion fluid inside the cochlea. So let's stretch the cochlea out, hypothetically speaking, and see what chambers are in there. So your cochlea, okay, you stretch it out. Just unwinding it. You will see that there are 3 chambers in the cochlea. Okay. The upper chamber, which is attached to your oval window. So this is the oval window. And that's where, again, the stapes is attached to. Attached to the oval window. That lets you into the upper chamber that we call your scala vestibuli. That's the upper chamber of the cochlea, or the outer chamber. That chamber continues with another chamber, we may call it lower chamber. This one is called the scala tympani. Okay. And that chamber opens up, or it dissipates its vibration into another window out here. This window here is called the round window. So oval window and round window. Then the center scala here is called your scala media, but it's also called your cochlear duct. The cochlear duct is another term for the scala media. Now, these 3 chambers contain a fluid. Okay, so the fluid that's in the scala media, that fluid here is called perilymph. This fluid in the lower chamber is also perilymph. And the fluid in the middle chamber here is endolymph. All right. And the outer chambers are connected by a passageway here. This part is called your helicochrema. All right. So 3 scalas with perilymph and endolymph. Now let's name some membranes. So the membrane here, this membrane here, that helps to form the scala media, this membrane is called your vestibular membrane. This one, the lower one here, is called your basilar membrane. Okay, so 2 membranes. And then sitting on the basilar membrane are some cells. We call them hair cells. So hair cells that sit on the basilar membrane. Okay, these are your hair cells. And these hair cells have these little things that stick up called cilia or stereocilia. And these stereocilia are attached to another membrane called your tectorial membrane. So hair cells and your tectorial membrane. Okay. So together, let's draw it right here. You have, this is your basilar membrane, and the hair cells on it. In fact, the hair cells form two groups. There's an outer group of 3 and an inner group of 1. Okay. So the outer group we call the outer hair cells. The outer OHCs, outer hair cells, and the inner group of 1 is called the inner hair cell. Okay. Again, these are attached to the overlying tectorial membrane. Different, but we keep it that way. So here is your tectorial membrane. Okay, so this structure here, this is called your organ of Corti. This is the structure that responds to sound. In fact, the hair cells, these hair cells, especially the inner hair cells, are linked to neurons that bring the information back. So these neurons, it says these are all inner hair cells, they will all be attached to neurons. Here are the neurons here. These neurons will form cranial nerve number 8 to carry information back to the brain about what's going on in terms of vibration for sound. Okay, so this bundle of neurons here make up cranial nerve number 8, along with some neurons as well from this part, your vestibular-cochlear nerve. All right, so imagine this: when sound vibrates, the stapes eventually, it pulls on the oval window, which does this, sends vibration of the perilymph. And that vibration will dissipate once that hits the round window. But along the way, it will also vibrate the basilar membrane, which in turn vibrates the organ of Corti, which causes them to fire, to send messages to the brain. And depending on the nature of the sound, if it's high frequency or low frequency sound, different hair cells get disrupted. And based on which cells are disrupted, that's how the brain knows what kind of sound it is. Is it a high-pitched sound or a low-pitched sound? All occurring right here, okay? Depending on what hair cells, especially what inner hair cells are being activated by the vibration. So let's do let's do the path of sound, the neural path of sound. Once sound is generated and pushed into the nerve number 8, where does it go next? So the path of sound. So we can start here. So again, here's your cochlea, right? So it sends neurons through nerve number 8. This is also bipolar. Nerve number 8. So nerve number 8, the auditory nerve or vestibular-cochlear nerve, will synapse into what's called the cochlear nuclei, which is in the pons, and then from there, those little ways still in the pons, to synapse into your superior olivary nucleus, also in the pons. And from there, third neuron goes up and stops in the inferior colliculus, right, of the midbrain. The fourth neuron goes up and stops in the medial geniculate of the thalamus. And then a fourth neuron goes and stops in the primary auditory cortex, which is in the temporal lobe. So it's a 5-neuron pathway from the cochlea to the cochlear nuclei, then to the SON, then to the inferior colliculus, then to the medial geniculate, and then to the primary auditory cortex. That is your typical 5-neuron pathway for sound. and it has to go all the way here for you to hear it, okay? And we won't worry about the vestibular pathway, which is a little bit different from this one. This is auditory, not for vestibular function. Okay, we'll stop there.